All right, a lot of your homework that you guys have been giving me for chapter 2-3, there's been a lot of errors on it. And the reason why there's been a lot of errors is if you look at the instructions that I've given you for section 2-3, the directions are very clear. On worksheet 2, there's a whole bunch of stuff you're supposed to do. And then it says factored form. Factored form is x plus 2 times x minus 1 times x minus 2/3. You with me? It should look something like that. If it is degree 4, I should see 4 parentheses attached by multiplication. If it's degree 2, I should see 2 parentheses attached by multiplication. If it's degree 3, I should see 3 attached by multiplication. Yes? So that's the biggest issue on the front of 2-3 worksheet 2. On the back, it's the last page that I am struggling with. Number 9 and 10. Again, I give you a line for the complete factored form. Many of you are just giving me the roots that I have up there for root 1, root 2, root 3. I don't want that. I want you to actually tell me what the factored form is. Again, putting it in parentheses. Do we all understand what your issue was with 2-3 worksheet 2? Okay, 2-3 worksheet 1. If you are looking at the back is the biggest issue. 9 and 10, you had to do synthetic division. If you didn't do synthetic division, I took points off, or I'm making you fix it. In problems 11, 12, 13, and 14, it says use the result of your synthetic division to factor the polynomial completely. What does it mean to factor completely? X minus a number times x plus a number times x plus a number times x minus a number, right? That is factored completely. If you found the roots but never factored it completely, I said fix. Do we all understand that? Okay, now I'm not giving you any notes today. We're going straight to homework, okay? So all I want is the factored form on today's worksheet, which is 2-5 worksheet 1. Everything else I want you to show on a separate sheet of paper. So you need to get out paper now. Do we all understand that? So get out some paper now. I hate to tell you this, but there are 8 problems, so you're probably going to need a solid 3 sheets of paper. Maybe 4. I'm just telling you, the more organized you are, the better you are going to be at this process. The less organized you are at this, the harder this process will be for you. Do we all understand that? Okay. Now, first things first, we're going to do number 1 and 3, and I believe number, I don't remember what else I put up there. Okay, let's start off with number 1. I changed all of those from 1, 2, 3, 4s to A, B, C, D's, E's. You with me? I just wanted you to know that. On your worksheet, I changed all the 1, 2, 3, 4s to A, B, C, D's and E's, okay, for the steps. So, letter A, it says to take this polynomial and find your P over Q values. So how do you find your P over Q values? Well, P over Q, what is P? P is your constant term, so that's going to be 16. And what are all the factors of 16? Plus or minus 1 and 16, 2 and 8, and then 4 times 4. Do you see how I wrote that? I did 1 and 16, I did 2 and 4, and then 4 times 4, which was meeting in the middle. We good? Now, what is Q understood to be? Q is your leading coefficient, which just happens to be 1. And what are all the factors of 1? Plus or minus 1. Now, that means my final P over Q list is I'm going to take every one of my numerator values and divide it by each one of my denominator values. So if I take every one of my numerator and divide it by 1, it is just going to be my numerator list. Do we all understand that? This is my P over Q list. Now, when we did this in section 2-3 worksheet, I made you find the biggest number in that list. Bless you, the biggest number in that list is 16. Now, what I want you to find is your window size. Your window size is going to be 1 unit to the left of that, which is negative 17, and 1 unit to the right of that, which is positive 17. Meaning if I put my window, whenever I graph this thing on the graphing calculator, between negative 17 to positive 17, all of my rational zeros will be within that range. Do we all understand that? Are we good? Okay, so part B, what does part B ask us to do? Part B says to use Descartes' rule of signs. So I have to do Descartes' rule of signs next. So how do I do Descartes' rule of signs? I count the number of sign changes in the original f of x function. So if I'm doing positive roots, I'm simply going to take my original function, which is this right here, and I'm going to count the number of sign changes. Positive 1 to negative 7 is 1. Negative 7 to negative 10, nothing. Negative 7 to negative 10 to positive 16 is my second sign change. So that means I have n equaling 2, but then I always have to do n minus 2, correct? So I'm going to have 2 or how many? 0 positive roots. Do we all understand that? I will have 2 or 0 positive roots. Now from there, I need to do my negative roots. How do I do my negative roots? I'm going to count the sign changes in f at negative x. Whenever I'm doing f at negative x, which powers have the coefficient change its sign? The odd powers. So 1x cubed turns into negative x cubed. Negative 7x squared stays as that. Negative 10x changes to positive 10x, and plus 16 stays. So I'm going to count the number of sign changes. Negative 1 to negative 7, nothing. Negative 7 to positive 10 is 1. Positive 10 to positive 16 is nothing. So that means n is equal to 1 here. So if I continue to do n minus 2, 1 take away 2 gives me negative 1. Can I do that? No, I can't do that. I have to physically count them and see them. There's either 0 or a number larger than 0. I can't have a negative quantity, which means I'm going to have at least one negative root. So now I'm going to come over here and I'm going to do plus, minus, imaginary, and total. Now, I can have 2 positive roots paired with 1 negative root. I have to have a grand total of how many roots?
3.
Why 3? It's the highest degree, correct? So I have to have a grand total of 3 roots. So how many are left to be imaginary in this row? 0. Okay, so now that means I can have 0 positive roots paired with 1 negative root. I still have to have a total of 3 roots. So how many are left to be imaginary? 2. Do we all understand this chart right here? Yes or no? Okay, well that's all great, because now what does part 3 say to do? It says to graph the polynomial. So what we're going to do is we're going to pull up our graphing calculator. And we are going to graph the function, which is going to be x cubed minus 7x squared minus 10x plus 16. Okay, and I'm going to hit enter. Now, according to my P over Q list, what's my window size that I need to be in? So I'm going to hit menu, window zoom, window settings. I'm going to make this a negative 17, arrow down to positive 17. I'm going to go by units of 1. I don't care about the Y max and the Y min. I don't care about that. Do we all understand that? I care about making sure that I can see all my possible rational roots. Now, what can you conclude by this graph? If we're looking at Descartes' rule of signs, what can you conclude? Look at that again. There's 1 negative and there are 2 positives. Do we all understand that? So if I go back to my Descartes here, I'm simply going to highlight the answer that I'm utilizing. Do we all see that? I know now that I have to have 2 positive roots, I have to have 1 negative root. Do we all get that? Now the next thing we're going to do is we're going to now find the roots of the calculator, utilizing the calculator. So I'm going to come back over to my calculator, and I'm simply going to hit menu, graph, analyze graph, and 0. I'm going to go to the left. I'm going to go to the right. I'm going to hit enter. 8, 0. Tell me, is 8 in my P over Q list? Yes. It is. So therefore, that's excellent. Because if I can find all of them out of my P over Q list, I don't have to make synthetic vision. Because I can see them and I already narrowed this down, right? So let's do it again. Menu, analyze graph, 0. Is 1 in my P over Q list? Yes, let's do it again. And then my last one is going to be -2. Is -2 in my P over Q list? Okay, what this means is, since I have confirmed that I'm going to have 2 positive and 1 negative, I simply have to write down my roots. Root 1 is going to be 8. Root 2 we said was 1, and root 3 was going to be -2. Do we all understand that? Yes or no? Since all of those are in my P over Q list, I'm simply not, it's not necessary to do synthetic division. It is not needed. And the reason why is because we found them all graphically. You with me? My roots are all rational, meaning they're not irrational and they're not imaginary. When my roots are irrational or imaginary, I'm usually forced to use synthetic division to get it down to degree 2 to use the quadratic formula. Let me say that one more time. If my roots are irrational or imaginary, I am forced to do synthetic division to get it down to degree 2 to use the quadratic formula. Do we all understand that? So since I found them all, I can simply now factor this into a 1 binomial, or 3 binomials, I should say, and that'll obtain the original graph. So x minus 8 times x minus 1 times x plus 2. If I were to distribute and FOIL all of that together, I'm going to get the original problem. Do we all understand that? We good? Okay, let's do the next one, number 3 together. So on your paper, what did I want on your paper for number 3 or number 1? This is the only thing I want you to write on your homework paper. The rest of the work is going to be on notebook paper. Yes? But I better see that factored form on your homework paper. Okay, number 3. Number 3, step 1, what do I do? What's it ask for? I need to do P over Q. So if I'm going to do P over Q, what is P? 1. What are all the factors of 1? Plus and minus 1, right? What is Q? 3. So what are all my factors of 3? Plus or minus 1 and 3. So now, what is my total P over Q value list? Well, I'm going to take 1 and divide it by 1, which gives me 1. I'm going to take 1 and divide it by 3, which gives me plus or minus a third. Do we all see that? This is my list. That's my P over Q list. Why is that helpful? Because my window size is going to be what? -2 to +2. Because my biggest number is simply going to be the 1. Do we all understand that? Yes or no? Now that's a really small window size for us, isn't it? Since it's a really small window size, that gives me a knowledge that I'm probably going to have fractional roots. Do we all understand that? Okay, makes sense? Okay, part B, what's it say to do? What do I do? Descartes' rule of signs, right? So if I'm doing Descartes' rule of signs, my positive roots. How do I find my positive roots? The sign changes in the original function. +3 to -1, there's 1. -1 to -3, nothing. -3 to +1, there's 2. So this means n is equal to 2. So that means I'm going to take n minus 2 from there. So how many positive roots can I possibly have? 2 or 0. Do we all understand that? Now from there, I need to go ahead and I need to find my negative roots. Well, how do you find negative roots? Negative roots are done by finding f at -x. Whenever I'm calculating f at -x, what powers have their coefficients change signs? So I keep 3x to the 4th. I change this to be a positive x cubed. I change this to a positive 3x, and I keep my constant sign. How many sign changes do I have in f at -x? None. So I have 0. So now I need my positive, negative, imaginary, and total roots. Correct? How many total roots should this thing have? It better have 4 roots. Do we see that? Okay. So over here, I'm going to have 4 roots every time. 2 can be paired with 0, and 0 can be paired with 0. Do we all understand that? But it has to be 4 both times. Now, how many are left to be imaginary in the first row? 2, because 2 positives plus 0 negatives plus 2 imaginary equals a grand total of 4 roots. How many remain to be in the bottom row? 4. Now, listen. This bottom row is not possible for you to find unless I give you one of the imaginary roots. Do we all understand that? So 99% of the time, you are going to literally have this only option, which is the first row. How do I prove that what I just said is correct? Graph it. So part C says to go ahead and graph this thing. So we're going to come over here, we're going to graph that function. And that function is going to be 3x to the 4th minus x cubed minus 3x plus 1. So if I hit enter, this is what I have. My viewing window needs to be from -2 to +2. I'm going to zoom in so that you can see that window to make things just a little bit easier. -2 to +2, and I'm going to go by units of 1. Again, I don't care about the y max and min, and I hit OK. Okay, now based upon that, what can you conclude? That there are clearly 2 positive roots. So that means if I'm back on my Descartes rule of signs chart, I have proven graphically that this is my option I'm going to be finding. Yes? Now, with that being said, I want to go ahead and find root 1 and root 2. Root 1, root 2, root 3, and root 4. Do you see how I'm putting all 4 roots up there? Because I have to find them all, don't I? So I'm going to go back to my graph and I'm going to find them. And I'm only going to be able to find 2 of them because those are the only 2 I can visibly see, correct? And the other 2 have to be imaginary. So menu, analyze graph, 0. And what do you find? That 1 is the first root. Is that in my P over Q list? Let's do it again. Menu, analyze graph, 0. Go to the left. Go to the right. And it gives me this decimal. This decimal is 0.333 repeating. What is that in fraction form? It is indeed 1/3. Do we all understand that? It is 1/3. I do not want decimals on this worksheet. Do not ever give me decimals. I always want the fractional rational equivalent. Do we all understand that? So I'm going to come back over here and say, oh, well, root 1 is 1, and the second root is going to be 1/3. I still have to find root 3 and root 4. I don't know them. Do we understand that? So then part D says to do synthetic division. Well, I have no choice. I have to do synthetic division to get this thing down to degree 1 so that I can physically do the quadratic formula to get the imaginary roots. Do we understand that? So I'm going to put 1 in my box for my synthetic division. I'm going to drop down variables. 3x to the 4th minus 1x cubed, 0x squared minus 3 plus 1. And just like we did before, 4, 3, 2, 1, 0. Am I missing any powers? No, I'm not, so I know I'm okay. So I'm going to go ahead and do this. Drop down the 3. 1 times 3 is 3, plus -1 is 2. Times 1 is 2, plus 0 is 2. Times 1 is 2, plus -3 is -1. Times 1 is -1 to give me 0 as a remainder. Why did I come up with 0 as a remainder? Because it is a factor. A factor is a root, which is a 0. So therefore, by the factor theorem, when you do synthetic division, your remainder must be 0. What degree is this now? This goes down to degree 3. From there, we're going to do synthetic division again at the value 1/3. What should the remainder be on that one? 0 as well. Drop down to 3. 3 times a third is 1 plus 2 is 3 times a third is 1 plus 2 is 3 times a third is 1 plus -1 is 0. Did I get what I needed to get? Okay, now what degree is this? This is degree 2. Well, since this is degree 2, what is the physical polynomial that I need to work with now? Excellent. Now this polynomial right here is what I have to do the quadratic formula on. Why? Because guess what? I already know that my roots have to be imaginary. Can I factor that? No, I cannot factor that. So I'm going to go to this page. So 3x cubed, or squared, sorry. (3x squared plus 3x plus 3 has to equal 0. Do I have a GCF? 3. So go fish. Pull out the 3, and that gives you an x squared plus an x plus a 1 is equal to 0. Then you are simply going to apply the quadratic formula here. X equals -b plus c minus the square root b squared minus 4ac all over 2a. What is a? 1. What is b? What is c? Okay, so very good. We're simply going to apply this formula. That's going to be a -1 plus or minus 1 squared minus 4 times 1 times 1 all over 2 times 1. Do we see that? Yes or no? So this is going to give me -1 plus or minus 1 minus 4 over 2, which is going to be -1 plus or minus the square root of -3 over 2, which is going to give me -1 plus or minus I square root of 3 over 2. You know what that means? I just found root 3 and root 4. What is root 3? -1 plus I square root of 3 over 2. And what is root 4? Very good. -1 minus I square root of 3 over 2. Yes? Now, how do I write this in its most factored form? Well, its most factored form means that I have to have x minus 1 times x minus 1/3 times x plus 1 minus I square root of 3 over 2 times x minus 1. And those should both be minus. I don't know what I was thinking. Okay, do we all see that? Oh, I forgot my parentheses. Okay, do we all see that? Yes or no? I'm sorry. This right here is the last step. That last step is what you need to make sure is on your worksheet part. Okay? I found root 1 and root 2 graphically. I used synthetic division on root 1 and root 2 to drop the polynomial down to degree 2. Once I got it down to degree 2, I looked to see if there was a GCF, and I pulled that GCF of 3 out. I then applied the quadratic formula. Why? Because I can never factor x squared plus 1x plus 1. That's never going to give me factors of 1 and never going to give me 1. It's either going to be 0 or 2. So by using the quadratic formula, that's what I get. Do we all understand this problem right here? Shall I start you with one more? Let's do one more. You have lots. You have 8 of them to do tonight for homework, so you may as well get one more. Okay. Now, the next one we're going to do is number 8. The next one we're going to do is number 8. So are we ready? What do I do first? P and Q values. So P is going to be what? It's going to be 6. So what are all my factors of 6? Plus or minus 1, 2, 3, and 6. Correct. What are all my factors of 6? What's my P over Q? My Q is 6. So again, I have all the exact same values. Now this is where things get really wonky. Okay? Now I'm going to highlight this so that you guys can stay with me. I'm going to take all those values and divide them by 1. So that's plus or minus 1, 2, 3, and 6. Do we see that? Yes or no? Does everybody see what I just did? Highlight this one. Now I'm going to take all those values and divide them by 2. 1 divided by 2 is 1/2. 2 divided by 2 is 1. Is 1 already in there? Do I have to repeat it? No. 3 divided by 2 is not in that list. What is 6 divided by 2? Is that in my list? Yes. So let's do the next one. 1 divided by 3. 2 divided by 3. 3 divided by 3. It's already in there. 6 divided by 3. Already in there. Go to the next one. That's going to be a 1/6. 2 over 6. What's 2 over 6 reduced down to? Is that in there? Yes, so I don't have to write it again. What's 3 over 6? 1/2. Is 1/2 in there already? Yes. How about 6 divided by 6? It's already in there. Do we understand that that is your complete list of P over Qs? Do you understand how I did that? This confuses students every year, getting that list. You don't have to put repeats in there. Okay? All right, next. What is my window size based upon that? My biggest value is going to be 6. So my value that I'm going to have is, one more time? -7 to +7. Do we all understand that? Now, here's what your brain needs to get right now. You may have some roots that you don't know the decimal of 1/6, do you? You know 1/2 is 0.5. You know that 3 over 2 is 1.5. You know that 1/3 is 0.333. You know that 2/3 is 0.66 repeating, right? But you don't know what 1/6 is, so you may have to do that. So if you get a wonky decimal that you don't know, it's probably 1/6. Does that make sense? Yes? Okay, from there, part B. What am I doing on part B? I'm going to do Descartes' rule of signs. So I have positive roots. How do I find the positive roots? Sign changes, right? Positive to positive, no. Positive, negative is 1. Negative to negative, no. Negative to positive is 2. So what does this tell you? 2 or 0. Very good. Okay, negative. Negative roots means that I'm going to change only the odd powers. So 6 to the 4th stays minus x cubed minus 20x squared plus 3x plus 6. Do we all see that? Yes or no? All right. Well, I have a positive to a negative, there's 1. Negative to negative, no. Negative to positive, there's 2. Positive to positive, no. So how many sign changes do I have? How many negative roots? 2 or 0. Okay. Let's do our chart. Positive, negative, imaginary, total. How many total roots does this polynomial have to have?
4.
Why 4? Because that is the degree of the original polynomial. And as such, you have to make sure that there's a total of 4 every time. Now, 2 positive roots can be paired with 2 negative roots. Or 2 positive roots can be paired with 0 negative roots. Do we see that? Which means that 0 positive can be paired with 2 negative, and 0 positive can be paired with 0 negative. Do we all understand that? Yes or no? I paired every positive with every option that was negative, and every negative with every positive option. Okay? I have to have a total of 4 each and every time. So how many are left in row 1 for imaginary? How many are left in row 2 for imaginary? How many are left to be in row 3? In the last row? Now, what do you probably conclude about this? Row 4 will not happen because I did not give you an imaginary root. Do we all understand that? Yes? So what do I do right now? I'm going to graph this thing. And that is going to be 6x to the 4th plus x cubed minus 20x squared minus 3x plus 6. And graph. Now, what's our window size needed to be? What did we say it was? -7 to 7. So I'm going to go ahead and I'm going to put that in there. I wouldn't have had to because I technically can see everything, but I want you to get used to that. So that's why I'm doing it. Do we see that, yes or no? Oh, man. Did not mean to do that. Okay, so I'm going to move my label out of the way here. And now I'm going to find my lovely little graphs. So 0 here, enter. 1.73. I don't know that decimal. Was that in my rational roots?
Is it 1/6?
It can't be 1/6 because it's over 1, right? So what can you conclude right now? It's not going to be imaginary. Why is it not going to be imaginary? Because I have 2 positive, I have 2 negative, right? So I know right now that this is my option. Do we see that? That's what I know immediately. And furthermore, since I can see them, they're either rational or irrational roots. But because I came up with 1.73, guess what? 1.73 is not in my P over Q list, is it? So what type of a root does 1.73 have to be? Is it a rational number or an irrational number? Irrational. Very good. So I'm going to come back over here. I'm going to do it again. Menu. Menu, analyze graph 0. I'm going to go over here and hit enter, go over here, and hit enter, and that gives me the 0.5. Is 0.5 in there?
No.
Yes, that's helpful. Menu, analyze graph 0. Ooh, what's that number?
2/3.
-2/3. Is that in my list?
Yeah.
Yeah. Menu, analyze graph 0. Let's go to the last one over here. Ooh, what is that number?
The same one.
The same one as that one. So could it be a plus or minus concept there? Probably. So I'm going to do synthetic division at 1/2 and -2/3. Why? Because when I graphed it, those are what I found to be my roots. So root 1 I said was going to be 1/2. Root 2 I said was -2/3. Root 3 and root 4 I don't know yet. Do we understand that? So I have to do synthetic division at those values. So I have 1/2 here. That goes, and I'm going to have a 6, a 1, a -20, a -3, and a +6. 4, 3, 2, 1, 0. I'm okay, right? So I'm simply going to do synthetic division. We're running out of time here, so I'm probably going to keep going. Okay? Drop the 6. 6 times 1/2 is going to be 3, plus 1 is 4, times 1/2 is going to be 2. This is a -18. Times 1/2 is -9. This is going to give me a 12. Negative times 1/2 is going to be a -6, which gives me 0. Is that what I wanted? Yes. So that drops me down to degree 3. Now I need to do it again. At this time, -2/3. Drop down to 6. 6 divided by 3 is 2, times -2 is going to be -4. That gives me a 0. Times -2/3 gives me a 0. Gives me a -18. -18 divided by 3 is -6, times -2 gives me a 12. And that gives me a 0. Yes? What degree does this put me at now? Degree 2. Well, that makes life super fun. Because now I have 6x squared minus 18 equals 0. 6x squared is equal to 18. X squared is equal to 3. Take the square root of both sides. x is equal to plus or minus the square root of 3. Did I just find my 2 remaining irrational? I sure did. So if I factor this, it's going to be x minus a half, x plus 2/3, x minus the square root of 3, and x plus the square root of 3. Yes? Pretty cool, right?
Yeah.
And you saw all 4 roots. 2 are rational and 2 are irrational. Have a great day. You know how to do the rest of your homework, yes? Great job today, guys. Excellent job. You got this.